Hello, third grade, and welcome to topic 13. In this topic, we're going to talk about fraction equivalences and comparisons. So we're going to look at equivalent fractions and comparing fractions throughout this chapter. Let's go ahead and start with lesson 1. So 13-1 is equivalent fraction using models. We'll go ahead and watch our short lesson video and then begin with our notes and guided practice together.
How can different fractions name the same part of a whole? Think about this question during the lesson. The Chisholm Trail was used to drive cattle to market. Ross's herd has walked 1/2 the distance to market. What is another way to name 1/2? What information does the problem give? What do you need to find? The problem states that Ross's herd has walked 1/2 the distance to market. You need to find another way to name 1/2. Different fractions can name the same part of a whole.
I know you can break a whole into lots of different parts.
Fractions that name the same part of a whole are called equivalent fractions. Find the missing values. You can use fraction strips. The fractions 1/2 and 2/4 represent the same part of the whole. 2 1/4 strips are equal to 1/2, so 1/2 equals 2/4. Another name for 1/2 is 2/4. You can find other equivalent fractions. Think about fractions that name the same part of the whole.
Drag the fraction strips. Complete the row of 1/2 strips. Then complete the row of 1/4 strips. Then make a full row of 1/8 strips.
Okay, now for this section, we can see that we have 1/2. So this is one out of the two parts. So we're only going to add in one more part over here to make it two of the two parts, or the whole. Now, for the 1/4 size fractions, we have one part out of 4 total parts. Remember, our denominator, our bottom number, tells us how many parts there are altogether. So here I have 2 pieces out of the 4 pieces that I need. So I need 2 more. So there's 1 and then 2. Now for the 1/8 size pieces, we know from looking at our denominator that we need a total of 8 pieces to make a whole. So to make a whole, we need 8 out of the 8 pieces. So here's 1, 2. Now you can see that 2/8 is the same thing as 1/4. 3, 4. Now here we have 4/8. So 1, 2, 3, 4/8 is the same thing as 2/4. That's also the same thing as 1/2. Here's 5/8, 6/8, 7/8, and then finally 8/8 to make one whole. So here's our one whole to show you what one whole looks like. One whole divided into 2 equal parts are called halves. When it's divided into 4 equal parts, it's called fourths. And when it's divided into 8 equal parts, that's called eighths.
For example, 1/2 equals 4/8. Which fraction is equivalent to 3/4?
Select your answer.
Now here, let's stop and take a look. So 3 of my 1/4 size pieces. I can't use the halves because it doesn't use a 1/2 size piece. It only uses part of it. So let's look at the eighths. Figure out how many eighths line up at the edge of 3/4. So we have 1, 2, 3, 4, 5, 6. So 6/8 is the same thing as 3/4.
3/4 equals 6/8. Now you know how different fractions can name the same part of a whole.
Okay, now before we move on, I want you to take a look at these numbers, 3/4 and 6/8. So how did we get from 3 to 6? How did we get from 4 to 8? So 3 times what gives me 6? And 4 times what gives me 8? So I know 3 times 2 will give me 6. I also know that 4 also times 2 will give me 8. So you can see that what we did here to find these equivalent fractions is we cut each one of these pieces into 2 parts. So we doubled the number of pieces that we have. So I did 3 times 2 to give me 6 and 4 times 2 to give me 8. I multiplied my numerator and my denominator by 2, and that gave me an equivalent fraction. So that's another way that you can use to find equivalent fractions. You have to multiply your numerator and denominator by the same number, or divide your numerator and denominator by the same number, but we'll get to that later. Now let's go ahead and get into our notes and our guided practice together. Now for our math notes, we're talking about equivalent fractions. So we're using models here. Now when we're using models, it basically means we're drawing it out so that we can see it. So our question that we're going to focus on for this lesson is, how can different fractions describe the same part of a whole? So if this is my one whole over here, these are my half size pieces. So remember, your denominator tells you how many pieces you have to make the whole. So 2 1/2 size pieces, or 4 1/4 size pieces, or 8 of my 1/8 size pieces. Now remember, equivalent fractions name the same part of a whole. So 1/2 is the same thing as 2/4. 1/4 over here is the same thing as 2/8. Since 1/2 is the same size as 2 of my 1/4 size pieces, that tells me that 1/2 is equal to 2/4. That means they are equivalent. They take up the same amount of space out of the whole. Now 1/2 is also the same size as 4 of my 1/8 size pieces. You can see that they line up over here. So 1/2 is equal to 2/4, and that's equal to 4/8. All of these sections take up the same amount of space out of the whole. They're just cut into smaller sized pieces. Now for this example, it says you can also show equivalent fractions using area models, so drawing. In both shapes, the same amount of the whole is colored, so they represent equivalent fractions or equal parts of the whole. Now here you can see this shape is cut into 6 pieces, or 1/6. This is cut into 3 pieces, or 1/3. Now, if we're looking at these two shapes, they're the exact same size. This one is just cut into smaller pieces. So over here, I have 4 of my 1/6 size pieces, or 4/6. And here I have 2 of my 1/3 size pieces that are colored, or 2/3. So 4/6 is equal to 2/3. Now remember what I was telling you about at the end of the video. How do we get from 4 to 2? How do we get from 6 to 3, or the other way around? How did we get from 2 to 4? How did we get from 3 to 6? So 2 times 2 gave me the 4. 3 times 2 gave me the 6. Now, some important things that I want you to remember while we're going through this. The numerator, remember, is the number of parts that you have. So over here, I have 4 out of my 6 total pieces. The denominator is the total number of pieces, not just the parts that are not colored. The denominator is all the pieces you have, or all the pieces you need to make a whole. And the numerator is the number of parts that you have. Now, this is really important. The bigger your denominator is, the smaller those pieces are, because you're cutting them into more pieces, or you're sharing them, that same whole. If you're thinking about it like a cake, you're sharing with more people. So if these were my 2 cakes, and this was cut into 1/6, and this was cut into 1/3, the people that are getting the 1/3 are getting bigger sized pieces, because they're only sharing between 3 people. But if you're sharing that same cake between 6 people, you have to make those pieces smaller so that everyone gets a piece. So this is something important to remember. The bigger your denominator is, the smaller your pieces are. The smaller your denominator is, the bigger your pieces are, because that means you're sharing with fewer people or you're cutting into smaller pieces. Now, when your numerator is the same number as your denominator, that means you have one whole. It's equal to one whole. So if you have 6/6, that means you have all of the parts of your cake, or you have the whole cake. Now, this is true for any number: 3/3, 100 hundredths, 50 fiftieths, 10 tenths, whatever it is. If your numerator and your denominator are the same number, it equals one whole. Now, another way to find equivalent fractions, this is what we were talking about with multiplying. To use multiplication, you need to multiply both the numerator and the denominator by the same number. You have to change them the same way for it to be an equivalent fraction. So 1/2 is equal to 2/4 because 1/2, if I break it into two equal parts, just like we were looking at up here, if I cut my 1/2 into two equal parts, I would have two 1/4 size pieces. 1/2 times 4 will give me 4 of my 1/8 size pieces. 1/3 numerator and denominator times 3 will give me 3/9. So that would be 3 of my 1/9 size pieces. These are equivalent because they're being changed the same exact way. Now, to find an equivalent fraction, so if I have 2/3 is equal to something over 9, first I have to think, how did I make my denominator of 3 into a denominator of 9 using multiplication? So I know from my multiplication facts that 3 times 3 is equal to 9. So if I multiply the denominator by 3, I must also multiply the numerator by 3. I can't do just one. I have to do both if I'm looking for an equivalent fraction. They have to get moved the same exact way. So if I did the denominator times 3, that means my numerator also needs to be multiplied by 3. So by changing both the numerator and the denominator in the same way, the fraction that you end up with afterwards is an equivalent fraction because it moves in an equal way. Now, if I have 4/8 is equal to something over 2, I can stop and think, how did I get from 4, or how did I get from 8 to 2? Or I can think of it in the opposite way. I can use the inverse. How do I get from 2 to 8? So I know 2 times 4 is equal to 8. So that means 8 divided by 4 is equal to 2. So if I want to make equivalent fractions, I need to change my numerator and my denominator the same way. So I can divide the numerator and denominator by 4 on the first fraction, or I can figure out what to multiply by 4 in the second fraction to make a denominator or a numerator of 4. So if I divide both the numerator, the top number, and the bottom number by 4, 4 divided by 4 is equal to 1. And then 8 divided by 4 is equal to 2. Now let's take a look at your guided practice together. For number 1, it says divide the second area model into 6 or 6 equal parts to show an equal fraction that is equivalent to 1/3. So we had our 1/3 one printed in our books, and we had it colored in. The second one, we cut into 1/6 size pieces. So I cut it into thirds, the same as the other one, and then I cut those down the middle in half. So now I have 1, 2, 3, 4, 5, 6. And then I had to color in the same amount or an equivalent amount of my second shape to match the area that was colored in on my first shape. So I know that my 1/3 is going to equal 2/6. Now when I start coloring, I see that right away. That whole first top bar is what got colored in. I also know that if I multiply to make a denominator of 6, I have to multiply that 3 times 2. So if I multiply my denominator times 2, I need to multiply my numerator also times 2. So 3 times 2 gave me the 6, and then 1 times 2 will give me the 2. For number 2, it says find the equivalent fraction for 1/4 using the fraction strip. So over here, they showed us what 1 whole looks like. They drew out the 1/4, and underneath we have 2 of the 1/8 size pieces. Now, since these two take up the same amount of space as the 1/4, that means they are also equivalent. That takes us to the end of our first lesson of chapter 13. If you guys have any questions, let me know. Otherwise, have an amazing day, 3rd grade. Take care. Bye-bye.